Sketch the solution to each system of inequalities. So let's graph this linear system of an inequality. So now we see two inequality statements. So what we have to do is we first have to graph each one individually. So let's start with the top one. Y is less than or equal to negative 2x minus 3. So right away I see my line has to be solid because of the less than or equal to inequality symbol. So first we graph our y-intercept, which is negative 3. Our slope, negative 2. So that means go up to left one. So up to left one, up to left one, up to left one. Okay. So let's graph that line. All right, pretty good. I'll just adjust the top a little bit so there's more of a straight line. All right, I've got to adjust the bottom. There we go, perfect. Of course, we need our arrowheads. Okay. So there's our line. Okay, and now we want to graph the other inequality. Let's use red for that one. So our other inequality, y less than negative 2/3 x plus 1. So in this case, we are going to have a dotted line, not a solid line because of the inequality symbol. It's just less than instead of less than or equal to. So our first point is the y-intercept of 1. Then our slope is negative 2/3, which means we go up to left 3. So up to left 3. And then we can also, from our original y-intercept point, go down to right 3. All right, and let's connect those points. But now we got to remember that our line is dashed or dotted instead of solid. And of course, arrowheads. Line's going forever. And now we have to figure out where are we shading. So let's go back to our first inequality. And we have to figure out from that blue line, where are we shading? To the right or to the left? So first thing we'll want to do is we want to figure out, are we shading to the right or left of that line? And we're going to do that by testing the point 0, 0 in the inequality. So we replace the x and the y with the value 0. So now we're going to see, is 0 less than or equal to negative 2 times 0 minus 3? So negative 2 times 0 is 0, minus 3 is negative 3. So 0 less than or equal to negative 3. Well, that is a false statement because 0 is bigger than negative 3. So that means we would shade on the side that 0, 0 is not on. So in that case, we would shade on the left side of that first line. Okay, so we drew the arrows to help us remember that. Now, let's test 0, 0 in the other inequality statement. So we have to see, is 0 less than negative 2/3 times 0 plus 1? Well, negative 2/3 times 0 is 0, plus 1 is 1. So is 0 less than 1? Yep, that is true. So that means we do shade on the side that 0, 0 is on. So for the dotted line, we also shade to the left. And so now we have to see, of the 4 regions created by the intersection of the 2 lines, which one of them do we shade? So the 4 regions I'm talking about, like this is 1, this is 2, this is 3, and this is 4. So of those 4, we have to figure out where do the shadings of both of the lines overlap. Well, definitely not in region 2 because none of them were shaded in. Region 3, the red line would be shaded but not the blue. And then region 1, the blue would be shaded, not the red. But if you look down here at the region I numbered region 4, down here, both the red and blue shadings would overlap. So that means that's our solution to this system. Okay, now let's look at our next system. So this problem is going to be very similar. The only differences are initial inequality statements are not written so that y is isolated. So we're going to just have to do that one extra step. We're going to have to get y by itself to help us with the graphing. So we have 3x minus y is greater than or equal to 1. So what we're going to want to do is we're going to subtract 3x from each side. Now we have negative y is greater than or equal to negative 3x plus 1. And we're almost there, but we have this negative y instead of y. So the next step would be to divide everything by negative 1. And this is a little trick about inequalities, but when you divide an inequality statement by a negative number, you actually have to flip the sign. Okay, so because we divided by a negative 1, we divided both sides by negative 1, that changes the inequality statement. So you have to flip it. So now we get y is less than or equal to 3x minus 1. And we have to graph that inequality statement. Okay, so let's begin with the graphing part. We see the y-intercept of negative 1. We make that point. Our slope, 3 over 1. So that means go up 3 over 1, up 3 over 1. And this is going to be a solid line because of the equal to part in our inequality statement, because y is less than or equal to. So let's connect the points. All right, got to adjust my line just a little bit. There we go. Let's add our arrowheads. Perfect. Okay, so now we have to figure out what side of the line are we shading. So we're going to test 0, 0 into our inequality statement. And I'm just going to adjust the line just a little bit to clearly show that 0, 0 is actually on the left side of the line. It kind of almost looks like our line goes through 0, 0, but that's not the case. Our line is slightly to the right of 0, 0. All right, so let's see what happens when we test 0, 0 into our inequality. So I'm going to test it into the original inequality, which is 3x minus y is greater than or equal to 1. So that's 3 times 0 minus 0. 3 times 0 is 0. 0 minus 0 is 0. So let's see, is 0 greater than or equal to 1? Let's think about that. Well, that is false because 0 is not bigger than 1. So for us, what that means is we have to shade on the side that 0, 0 is not on. So that means we will be shading to the right of this line because 0, 0 didn't work. All right, now let's look at our next inequality. Our next inequality is x x plus y less than 3. So we first have to get y by itself. So we have to subtract x, and we get y is less than negative x plus 3. Now in this case, our line is going to be dotted because y is less than negative 3. So let's begin that graph. And the first thing we see is that our y-intercept is positive 3. So up here we have our first point. And then our slope is negative 1 over 1. So that means go up 1 to the left 1, up 1 to the left 1. Okay, so I go up 1 to the left 1, up 1 to the left 1. Or you can go down 1 to the right 1, down 1 to the right 1. All right, there we go. Let's connect our points. But of course we have a dotted line this time. Okay, arrowheads. There we go. And again, we have to test the point 0, 0 to figure out which side of our line, dashed line in this case, has to be shaded. So using our original inequality, x plus y is less than 0. Oops, sorry, not our original inequality is x plus y is less than 3. So once we substitute 0, 0 in, we get 0 plus 0 is less than 3. So we get 0 less than 3. Let's think about that. True or false? That is true. So that means we shade on the side that 0, 0 is on. And for the dotted line, that means we are going to shade the left side of the line. And so now we think about, okay, where are the shadings overlapping? And if we look carefully, we see that down here, this area I highlighted in yellow, we see that the shadings for the solid line and dotted line overlap. So that is the solution to this inequality. And that means any point in this highlighted region will make both inequalities true.